Hello Matrix. We're here today to talk about something quite phenomenal, the cyclic universe theory, and how it intertwines with one of the fundamental laws of physics, the second law of thermodynamics. As some of you may know, the cyclic universe theory posits a tantalizing scenario. Our universe is not unique, but merely a chapter in an infinite series of universes, each born from the ashes of its predecessor, in an unending sequence of big bangs and big crunches. It's a captivating idea, isn't it? But hold on, because we encounter a snag when we consider the role of entropy. Entropy, loosely defined, is the measure of disorder in a system. The second law of thermodynamics, a pillar of physics, states that in an isolated system, entropy will always increase over time, pushing the system towards a state of maximum disorder or equilibrium. If our universe is considered a closed system, its total entropy should, by this law, always be on the rise. This poses a major challenge to the cyclic universe theory. If each universe inherits the entropy from its predecessor, wouldn't that mean that each subsequent universe starts with higher entropy than the one before it? This would seem to imply that there must have been a first universe, one that started at a minimum level of entropy, because a universe before it would have ended at this lowest entropy state, a contradiction to the idea of an infinite series of universes. However, the question then arises, could the laws of physics change under extreme conditions, like those of a contracting universe, heading towards a big crunch? Could entropy actually decrease in such a situation, resetting the cosmic clock, and making way for a fresh universe to emerge with lower entropy? This question is still a topic of intense debate and research in the scientific community. As of my last knowledge update in 2021, there's no widely accepted theoretical framework that allows for entropy to decrease in a collapsing universe. The second law of thermodynamics is understood to be universal and not contingent on the expansion or contraction of the universe. So despite the challenges that the second law of thermodynamics presents to the cyclic universe model, why is this idea still worth considering? Well, the answer lies in its philosophical appeal and its potential to answer some of the biggest questions we have about the universe. Consider this. The cyclic universe model provides a natural answer to the question of what caused the Big Bang. If each universe's big crunch sets off the next Big Bang, then we have an elegant, self-contained explanation for the creation of each universe. This theory would suggest that our universe is not a one-time miracle, but part of a grand cosmic cycle. But that's not all. The cyclic universe model also offers a potential resolution to the issue of why the entropy of our universe appears to be so low, especially near the Big Bang. In this cyclic model, the high entropy state of a universe's end becomes the low entropy state of its successor's beginning, if the entropy is somehow reset during the Big Crunch. While this idea is still highly speculative, and indeed faces significant challenges when we consider our current understanding of the laws of physics, it's an intriguing avenue of exploration that showcases the boundless creativity and curiosity that drives scientific inquiry. The possibility of an eternal cyclic universe reminds us that even in the realm of the most rigorous and hard-nosed science, there is still room for wonder, speculation, and the thrill of exploring the unknown. And so, we've journeyed together through the fascinating possibilities of the cyclic universe theory, and explored how it grapples with the challenge of entropy. We've seen that while this theory offers some intriguing possibilities, it's still a topic of ongoing debate and research in the scientific community. In the end, while the cyclic universe theory is beautiful and appealing, it reminds us that the pursuit of scientific truth is never straightforward. As we continue to gaze into the cosmos and unravel its mysteries, we must always be ready to test our assumptions, challenge our beliefs, and be willing to follow wherever the evidence may lead us. Thank you for joining us on this cosmic journey, Matrix. We hope you enjoyed today's dive into the mysteries of our universe. Don't forget to comment with your thoughts on the cyclic universe theory, and if you haven't already, hit that subscribe button. Here at WS Matrix, we're all about exploring the fascinating world of science and artificial intelligence, and we'd love to have you on board for our future adventures.